Hi, I'm Miss Iris.
Hi, I'm Miss Hall, and this is Lesson 60, Sequences. A sequence is an ordered list of numbers. A finite sequence is a function that has a limited number of terms and whose domain is a finite set. The values in the range are called the terms of the sequence. An infinite sequence is a function that continues without stopping and whose domain is the set of positive integers. Here are examples of a finite sequence and an infinite sequence. Right, so a finite sequence, in this case, it is just 4 terms, the domain being 1, 2, 3, 4, and the range being the terms 2, 4, 6, 8. An infinite sequence goes on forever, and we start with term 1, 2, 3, 4, and we keep going all the way to infinity. A sequence can be specified by an equation or a rule. For example, both sequences above can be described by the rule a sub n equals 2n, or f of n equals 2n. And in this lesson, we're going to do two things. We're going to see a rule, and we're going to have to write out the first terms of the sequence. And then we're going to work backwards. We're going to be given the first terms of a sequence, and we're going to have to find the rule. Example 1, writing the terms of a sequence. Write the first 6 terms of A. So we're going to begin with A sub 1 equals 2 times 1 plus 5. That is the first term of this sequence, right? I just replaced n with 1, and now I'll replace n with 2. So 2 times 2 plus 5. And now replace n with 3. 2 times 3 plus 5. 2 times 4 plus 5. So the first 6 terms, I'm going to have to do n1 through n6. Now let me simplify these. 2 times 1 plus 5 is 7, 9, 11, 13, 15, 17. So I could write out this sequence as 7, 9, 11, 13, 15, 17. And those are the first 6 terms. 1, 2, 3, 4, 5, 6. Okay. I don't need that last comma. Now we have a sequence written in the other notation, written in function notation. Same idea. I am finding the first 6 terms. Right, so I'm setting n to 1, and then to 2, and so on. I'm going to put a bunch of templates down for me, and then I'll fill in the end value. 1, 2, 3, 4, 5, last one. Okay, so n is 1, n is 2, 3, 4, 5, 6. Now let's evaluate. Negative 3 to the 0 is 1. Negative 3 to the 1 is negative 3. Negative 3 to the 2 is positive 9. Maybe you're able to tell that we're just multiplying these terms by negative 3. So I get negative 27, positive 81, negative 243. So the first 6 terms are 1, negative 3, 9, negative 27, 81, and negative 243. In example 1, we were given a rule and we had to write a sequence. And now we're given a sequence and we have to write a rule. When the terms of a sequence have a recognizable pattern, you may be able to write a rule for the nth term of a sequence. So, writing rules. Describe the pattern, then write the next term, and write a rule for the nth term of the sequence. Okay. I'm going to rewrite the sequence. We have -1, -8, -27, -64. Okay, and then above it, I'm going to put the domain. So this is the first term, second, third, fourth, fifth. So I'm almost creating a table here. Now I'm seeing if I see any pattern. Okay, well, I recognize that my range, these bottom values, are all cubes of the top number negated. Now, don't stress out if you don't see that. It is very unlikely that on a Regents exam you'll have to write a rule based on a sequence. It's going to be more like the try. Well, they'll give you the first terms of a sequence and you'll have to identify the rule from 4 provided rules. Okay, but in this example we're supposed to create a rule. So I see that 1, 8, 27, those are all cubes. This is, switch colors, -1 cubed, -2 cubed, where I cube it and then negate, -3 cubed, -4 cubed. I don't need those parentheses, so this next term will be -5 cubed, which would be 125 negative. Okay, so I can now write my rule. I can write it as a sub n equals -n cubed, or I could write f of n equals -n cubed. In sequences, it's common not to use an x, but to use an n. Right? So our domain is our n values starting at 1, and our range is our list of numbers. Okay, that is pattern A. Pattern B. Okay, I'll start with a smaller table. We have the first term is 0, second term is 2, third term is 6, fourth term is 12. I've got to find the fifth term. 0, 2. Okay, I'm not seeing this right away, so I'm going to go back a couple of units ago and I'm going to look for the differences in the range. So these are 2 apart, 4 apart, 6 apart. That is not a common difference. The first difference is not common. Let me look at the second difference. The difference of those differences is common. So this means it's a linear if those are common. The second difference is being common means it's a quadratic. So my rule must have like n squared. So let me see. This first term, if I do 1 squared, how do I make that 0? 1 squared minus 1 is 0. And then 2 squared is 4 minus 2 is 2. 3 squared minus 3. Okay, so it's n squared minus n is my rule. Okay, so let me stress that for right now, this example 2 is all an exercise in recognizing patterns. Can you figure out how this is growing and find the next term. And I forgot to find this next term. For 5, for the fifth term, it would be 5 squared minus 5, which would be 25 minus 5 would be 20. Okay. Do not freak out if it's hard for you to see these rules. Again, on most standardized exams, if you're given a question like this, you're going to see it in the try where they give you the first few terms and you have to match it to the right rule. And so the key thing there is knowing that the first term is knowing this domain is 1, 2, 3, that those are your n values.